Before starting to get into architecture and use cases, it is important to take a moment and reflect on the nature of intelligence, as that is the primary thing enabling Agentic AI. If we look up the definition of intelligence in Wikipedia, we'll find the following. Intelligence has been defined in many ways: the capacity for abstraction, logic, understanding, self-awareness, learning, emotional knowledge, reasoning, planning, creativity, critical thinking, and problem solving. It can be described as the ability to perceive or infer information and to retain it as knowledge to be applied to adaptive behaviors within an environment or context. There are a few core concepts here that must be highlighted. 1. The significance of the role of abstraction in both the creation and usage of intelligence. 2. The definition of intelligence as the ability to perceive or infer information and to retain it as knowledge. 3. Enabling adaptive behaviors within an environment. Every time one hears the words data, information, or knowledge, like in the above definition, one must be reminded of the DIKW pyramid. That pyramid shows how each layer is built upon the previous one and what the requirements are to travel from data to information to knowledge and wisdom, and what each of those truly means. Notice the below, for example. 1. Intelligence is needed to go from each level to the next. 2. The process that actually occurs to go from one level to the next involves learning. 3. The depth of understanding increases at each subsequent level. 4. Abstraction is at play at each step. Keeping all of that in mind, let's now have a look at the definition for artificial intelligence. Artificial intelligence, in its broadest sense, is intelligence exhibited by machines, particularly computer systems. It is a field of research in computer science that develops and studies methods and software that enable machines to perceive their environment and use learning and intelligence to take actions that maximize their chances of achieving defined goals. Such machines may be called AIs. What's important to highlight again in this definition is the ability to perceive the environment and to take actions using intelligence and learning to go from one to the other. In other words, an agent can be described using this classic picture, an entity that can perceive, analyze, and take actions in an environment. Which is indeed also the meaning of the word agency in philosophy and sociology. That is the capacity of an actor to act in a given environment. Hence, Agentic AI is an appropriate term for autonomous systems that can make decisions and perform tasks with limited or no human intervention. In this course, we will learn about the primary components and the architecture that is required to build such systems. In addition to the above, I would also like to take the chance to bring an additional perspective here. Although in this course we are going to focus on the advances in AI that are now possible thanks to the LLMs, having a historic perspective on AI and computer science as a whole will enable a timeless understanding of the vision and mission of computer science and of AI specifically towards humanity. I think this is best captured in two seminal papers that I would like to briefly introduce. The first one is a paper by Vannevar Bush titled As We May Think. It is from the year 1945, just around the time that the first primitive computers by today's standards were emerging. In the paper, he takes on the position that we as humans have a responsibility to extend the powers of the mind and command over the inherited knowledge of the ages. It is a seminal paper that helps shape the relationship between thinking man and the sum of our knowledge and provides great clarity on the role of computers and AI in doing so. In the absence of an actual computer at the time, he describes it all using an imaginary machine called the MEMEX, memory index. And yet, the vision holds true even today. he delves into various aspects of extending, storing, and consulting humanity's knowledge, which he calls the record of the species. And in a later version, he even touches on topics like voice-controlled user-propagated learning and many other ideas that are still considered advanced today. The second paper I would like to bring to your attention is one from Dag Engelbart, titled A Conceptual Framework for the Augmentation of Man's Intellect from 1963. Dag Engelbart was, in his own right, strongly inspired by the MEMEX paper, and he took it to a practical level, which then led to major inventions in personal computing. These include the Windows interface, hypertext, graphics, navigation, video conferencing, the mouse, word processing, revision control, and collaborative real-time editing, among many other things. These two examples show how clearly the vision and mission of computer science and AI can be formulated, which will then help us shape a clearer perspective on where we are going with AI. Now that we've briefly explored the foundational idea of intelligence and a historic vision and mission for computers and AI, we are ready to start diving deeper into how these agentic AI systems can be built. Let's continue.